All right, welcome to section 4.1, classifying triangles. So, what is a triangle? A triangle is formed by joining three non-collinear points with line segments. So basically, it's a figure that has three sides. So we can classify triangles two different ways. We can classify a triangle by its side lengths or by its angle measures. There's three different classifications for side lengths, and there's three different classifications for angle measures. An equilateral triangle means that all the sides are congruent. So I like to remember this one. Equa means equal, so all three sides are equal. 7, 7, 7, or we use one tick mark to denote that all the three sides are the same. Now, if this one had two tick marks, now the three sides would not all be the same side length. So they have to have the same number of tick marks to show that they are the same measure. So this means since they all have one tick mark, they're all congruent. An isosceles triangle is two congruent sides, so 8 and 8. And over here we have two tick marks and two tick marks showing that these are the same length. Now it doesn't necessarily have to be that there's two tick marks here. It could just be one mark and one mark, but that's showing that these two sides are congruent, which means that it's an isosceles triangle. And the third one is a scalene triangle where there are no congruent sides. So 4, 8, and 11, none of them are the same measure. And so we call this a scalene triangle. Also, this triangle has no congruent tick marks, so we call it scalene. Because there's nothing marked, it means none of the sides are the same length. So here we have 4, 4, and 4, which means that all three sides are congruent, and therefore we call it an equilateral triangle. Here we have 2, 3, and 4, so none of those side lengths are congruent, which means we call it a scalene triangle. And last but not least, if we have two sides that are congruent, for example, 6 and 6, we call it an isosceles triangle. So it has to be exactly two sides that are congruent in order for it to be an isosceles triangle. So a couple more examples. Here we have two sides that are congruent, 8 and 8. And so this is called an isosceles triangle. This one has 2, 2, and 2, so it has three congruent sides, so we call it an equilateral triangle. Equa means equal, so equilateral. And here we have 7, 6, and 10, so those are three different lengths, so none of the sides are congruent, so we call it a scalene triangle. So that's the first way to classify a triangle, is by its side lengths. The second way to classify a triangle is by its, oops, I'm trying to go forward. Okay, second way to classify a triangle is by its interior or inside angle measures. If all three angle measures are the same, so if they're all equal, we call it an equiangular triangle. So equiangular means all interior angles are congruent. So for example, they're all 60 degrees, or they can be marked by one tick mark each, indicating that they're all the same measure. So if we have an equiangular triangle, every time if you have an equiangular triangle, all three angles have to be 60 degrees. That's the only three things that are equal in an equiangular triangle. So since these are all marked congruent, we know that each angle measure is 60 degrees. An acute triangle is where all the interior or inside angles are acute, which means that they're all less than 90 degrees. So 72, 35, and 73 are all less than 90 degrees, so this is called an acute triangle. And the last one is an obtuse triangle. Oops. And an obtuse triangle is where we have one obtuse interior angle. So here we have 105 degrees, which makes it an obtuse triangle. So obtuse means greater than 90 degrees. So 105 is greater than 90 degrees. We only need one obtuse angle in order to make it an obtuse triangle. So here, the third one we have is a right triangle. And this is where one of the inside angles is a right angle, which means 90 degrees. There only can ever be one right angle. So here, since we have one right angle indicated by the box, we call it a right triangle. So, for example, classify each triangle by its side lengths and its interior angle measure. So we're going to classify using side lengths and angle measures. So here our side lengths, we have 2 side lengths that are congruent, which means that it is an isosceles triangle. And all of our inside angle measures are less than 90, and therefore it is an acute triangle based on its angle measures. Here we have 3 side lengths that are different, 3, 4, and 5, which makes it a scalene triangle by its side lengths. And then classified by its angle measures, it has 1 right angle indicated by the box, so we call it a right triangle. Here we have 6.4, 5.8, and 9 for side lengths, which is 3 different measures, so we call this a scalene triangle. And if you look at the angle measures, we have 40, 45, and 95 degrees. 95 degrees is greater than 90, which is an obtuse angle, and therefore this is an obtuse triangle. Here we have 2 side lengths that are congruent, marked by these 2 tick marks. So this is an isosceles triangle, and we have 1 angle measure that's greater than 90, which is 120 degrees, so it's an obtuse triangle. So this is isosceles and obtuse. 6.2, 7.6, and 7 for our side lengths makes it a scalene triangle because there are no congruent sides. And 50, 60, and 70 for our angle measures, those are all less than 90, which makes it an acute triangle. So this is a scalene and acute triangle. Here we have 2 side lengths that are congruent. So this is an isosceles triangle. We have just these 2 that are marked congruent, and all of my inside angle measures are less than 90 degrees, which makes it an acute triangle. So this is isosceles by the side lengths, acute by the angle measures. And again, this is called classifying triangles. And the last thing for this lesson, the vertex is a point that joins 2 sides of a triangle. So for example, we have vertex A, vertex B, and vertex C. So it's just the point of a triangle. And then the opposite side is the side across from an angle. So for example, across from angle A, so here's angle A, or vertex A, across from angle A is side BC or CB. And since there's 2 endpoints, we call it a segment. So the opposite side of angle A is segment BC. Right? So opposite means across from. If we look at angle B, right, the side that's opposite of angle B is segment AC or segment CA. And then if we look at angle C, the side across from angle C, or opposite, across from opposite mean the same thing. So the side that's opposite of angle C is segment AB or segment BA. Doesn't matter which one you call it.